Imagine waking up. The sky isn't blue anymore. It's grey. Every breath tastes like ash. Crops begin dying. Airplanes stop flying. Entire states are evacuated. Not because of war, but because Yellowstone has finally awakened. You're standing on a boardwalk in Wyoming, and the ground beneath your feet is breathing. Steam rises from a pool the color of a bruise. Somewhere below you, 3 miles down, sits enough molten rock to bury an entire state 5 feet deep. No one alive has ever seen what this place is truly capable of. But the evidence says it's happened before. 3 times. Yellowstone doesn't look like a volcano. There's no cone. No lava creeping down a slope. Just geysers, hot springs, and 46 seismometers quietly listening to a system that hasn't fully emptied itself in over 600,000 years. That's the strange part. The thing everyone fears isn't hiding. It's the most watched volcanic system on Earth. And still, somehow, it feels like a secret. So what if it erupted tomorrow? Not in a million years, not as a metaphor, tomorrow. Picture the park on an ordinary morning. Tour buses idling in the lot. A ranger pointing out bison crossing the road. Nobody looking down. That's the thing about Yellowstone. Its violence is always pointed downward, away from where anyone can see it, which is exactly why it's so easy to forget it's there at all. The first sign wouldn't be dramatic. It would be small. An earthquake swarm, dozens of little tremors clustering under the caldera floor. Yellowstone gets these all the time. Most mean nothing. In an average year, the park records more than 1,500 small quakes, and almost none of them make the news. But imagine this swarm doesn't stop. Imagine the magnitudes start climbing, week after week, and the ground itself begins to rise, not by centimeters, but by meters. That's the threshold. That's the line between background noise and something the Yellowstone Volcano Observatory has never actually recorded. What would that feel like, if you lived nearby? Not sudden. That's the unsettling part. It would feel like weeks of low-grade dread. Wells running warmer than usual. Familiar hiking trails closed without explanation. A hum in the ground you can't quite place, the kind you'd almost convince yourself you imagined if the neighbors weren't feeling it too. Jake Lowenstern spent 15 years as scientist in charge of that observatory, and he said the build-up to something this size likely wouldn't look subtle at all. It would look like the Earth panicking. Harmonic tremor. Gas emissions spiking. New cracks venting steam where there were none before. In this scenario, the network catches it early. Weeks, maybe months of warning. Enough time to evacuate the park's roughly 4 million annual visitors and the towns closest to the caldera rim. Then it lets go. A vent breaks open where the crust is thinnest, and a column of ash and superheated gas punches into the sky, faster than a jet climbing after takeoff. Within minutes, that column can reach the stratosphere. Within hours, it collapses under its own weight, and the collapse is worse than the launch. Because when a column that tall falls back down, it doesn't fall as ash. It falls as a pyroclastic flow, a ground-hugging wave of gas and rock moving faster than a car on a highway, hot enough to strip a forest to bare earth in seconds. Montana, Wyoming, Idaho. Anything close would be gone before it understood what was happening. There would be no rebuilding in that radius. Not for a long time. The immediate zone wouldn't just be damaged. Geologists describe it as swept clean, scoured down to rock, the way a wildfire clears brush, but on a scale that erases roads, towns, and forests in the same breath. And that's only the part of the disaster that stays close to home. That's the part people picture when they imagine this. But it's not the part that would actually reshape the world. The real damage travels on the wind. USGS researcher Larry Mastin modeled the ash dispersal for a future Yellowstone supereruption, and the numbers are almost hard to process. Denver and Salt Lake City, both within about 900 miles, would be buried under ash measured in feet, not inches. Roofs collapsing under the weight. Farther out, in Chicago and even San Francisco, ash would still fall thick enough to shut down engines, choke water supplies, and turn breathing outdoors into a health hazard. And because ash particles act like tiny magnets for moisture in the atmosphere, the fallout wouldn't stay dry. It would trigger torrential rain, turning ash into wet cement that clogs rivers, collapses power lines, and floods everything downstream. Here's the part that should genuinely unsettle you. This has already happened before, just not at this scale, and history recorded it in real time. In 1815, Mount Tambora, in what's now Indonesia, erupted with a fraction of the force scientists estimate a full Yellowstone supereruption could unleash. It was still the most powerful eruption in recorded human history. The ash and sulfur it threw into the stratosphere circled the planet, dimming sunlight for more than a year. 1816 became known as the year without a summer. Snow fell in June across New England. Crops failed on 3 continents. Famine and disease followed the darkness. Tambora is the closest thing history has to a rehearsal for what a Yellowstone-scale event could do, and it wasn't even the same category of eruption. So which is it? Total annihilation or something survivable? There are 2 competing pictures of what happens next, and both are grounded in real research, not speculation. The first says catastrophe on a civilizational scale. Global temperatures drop for years, maybe a decade, as sulfur aerosols block sunlight. Growing seasons shorten or fail outright across the northern hemisphere. Agriculture, already stretched thin, feeding a planet of billions, buckles under ash-contaminated soil and cooled climate. In this version, the eruption itself kills relatively few people directly. The famine and disruption that follow kill far more. The second picture is more measured, and it comes from scientists like Michael Poland, the current scientist in charge at the Yellowstone Volcano Observatory. He's pointed out that the word supervolcano makes people picture only the worst-case scenario, when in reality, the vast majority of Yellowstone's activity over the last 2 million years has been small. Roughly 80 eruptions between the 3 giant ones, mostly lava flows that never left the park. In this view, even if Yellowstone erupts again in our lifetimes, the odds strongly favor something local and survivable, not a planet-altering blast. And then there's the twist, the detail almost nobody expects when they start reading about. According to the USGS itself, the magma chamber underneath Yellowstone right now is only 5 to 15% molten. The rest is solid rock, still hot, but not liquid enough to erupt. Scientists aren't even convinced there's currently enough eruptible magma beneath the caldera to produce another supereruption at all. The annual odds of one happening, based on the historical pattern, work out to something like 1 in 730,000. You are, statistically, staggeringly more likely to die from almost anything else you can name. The mystery, then, isn't really whether Yellowstone will erupt again. It's why we've built an entire mythology of imminent doom around a system that its own watchers say shows no signs of waking up. Every earthquake swarm makes headlines. Every viral video of a bison acting strange gets read as prophecy. Why do we do that? Maybe because Yellowstone represents something we can't quite sit with. A reminder that the ground we build our lives on is not permanent. That the same heat powering Old Faithful, the same beauty drawing 4 million visitors a year to photograph turquoise pools, sits directly above a reservoir capable of ending civilizations as we know them. We don't fear Yellowstone because it's likely. We fear it because it's proof that the planet doesn't need our permission. That tension, between wonder and dread, is exactly what keeps people coming back to stare into those hot springs. It's the same tension that made Tambora's ash cloud feel to people in 1816 who had no idea what caused their endless winter, like the world itself had turned against them. Farmers in Vermont wrote about frost in July and had no framework for why. They blamed sunspot. They blamed divine punishment. Nobody thought to blame a mountain on the other side of the planet, because nobody yet understood that the Earth was connected that closely. We understand that now. We have the seismometers, the satellite radar, the gas sensors, the historical record of Tambora sitting right there as proof of concept. And still, the fear hasn't gone away. If anything, it's louder, amplified by every video of a strange acting bison and every headline about a minor tremor. What's changed isn't the danger. It's how loudly we talk about it, and how little that volume has to do with the actual odds. Think about what that says about us. We built the most sophisticated volcano monitoring network on the planet. 46 seismometers, 26 GPS stations, satellites passing overhead multiple times a day, all trained on one patch of Wyoming. And the more precisely we watch it, the more comfortable the scientists running that network become telling us it's probably fine. Yet the myth persists anyway. Overdue. Ticking time bomb. Ready to blow any day now. None of that comes from the data. It comes from something older in us. The same instinct that made a Roman farmer nervous about Vesuvius, or a Minoan sailor wary of Thera. We've always lived near things bigger than us, and we've never fully made peace with them. So you're standing on that boardwalk again, steam curling past your boots, the ground quietly breathing beneath you. 3 miles down, the same molten rock that carved this landscape into geysers and rainbow pools waits, mostly solid, mostly silent, exactly as it has for tens of thousands of years. No one alive has seen what this place is truly capable of. But now you know the evidence. And maybe that's the real discovery. Not that Yellowstone could end the world tomorrow, but that it hasn't, for 600,000 years. And the scientists watching it most closely are the ones least convinced that it's about to start.